I'll record right now.
Okay.
I should probably minimize this.
No, it's
Like,
fine. I think
here.
people like to see a speaker there.
Okay.
Okay. Should we get started?
Okay. Control.
Right, all recorded.
All good to go.
Okay, let's get started.
Okay. Can everybody hear me all right? Okay. Let me know if you can't hear, can't see. But without further ado, we'll go ahead and get started. 1.5 times Berkeley time. So welcome to the Introduction to Full Stack Development decal. Congratulations on making it through the application process. We hope that you will enjoy your time here, learn a lot. By the end, we hope that we've given you the skills that you need to succeed in whatever your next venture might be. Maybe that's with the club, maybe that's in an internship, maybe that's in your personal project, whatever it might be. We strive to help you reach those goals. And over the course of this semester as a class, we hope you all come together with a love and passion for web development, just like your amazing course staff. So with that, I will go ahead and introduce myself. So my name is Drew. I'm a second-year bioengineering and EECS major from Santa Clarita, California. Don't ask why bioengineering, because I don't have a good answer. Other than that, I am the co-VP of education for web development at Berkeley. So web development at Berkeley is the club that sponsors this decal, and it's the reason why we're all here today. With that, I'll hand it off to my amazing co-VP.
Thank you, Drew. All right, yeah, nice to meet everyone. And yeah, this is our first time doing an in-person decal, which is really exciting. It's been multiple iterations since we've had like an education branch, but yeah, it's really exciting to have it in person and to see all of your lovely faces. So a little bit about me. I'm also your co-VP along with Drew and Kimberly. I'm a sophomore studying computer science. A little bit about me and WDB. I was in WDB since like 4 semesters ago. So I've had experience as both a developer and course staff. And yeah, I absolutely love it in the club, and I absolutely have a really, really strong passion for teaching, which is why after I took the education branch myself, I'm back for many, many semesters, and now I'm heading the whole decal. So yeah, I think that's pretty much all I have to say for me, but I do want to introduce all our other lovely course staff. So do you guys want to come up, introduce yourselves?
Or you can just stand up and turn around, give a 1 or 2 sentence.
Yeah.
Spiel by yourself. Just
go
in order.
Samar.
Okay, so I can go first. Hey guys, nice to meet you. My name is Samar. I'm a junior studying computer science, and I'm a full stack TA, so ask me questions about almost anything relating to course content.
Hi everyone, my name is Alex. I'm a graduating senior, also studying computer science, and I'm also a full stack TA. So if you have any question about anything, please ask me. And yeah.
Hi, I'm Rachel. I'm a senior. I study environmental science and data science. I am a back-end TA, so don't ask me anything about anything. But yeah.
And I'm a third year studying computer science, and I'm going to be a front-end TA this semester. So don't ask me anything about the back-end. Yeah, had to do it.
I'm studying data science as yet. I'm a design TA, so please don't ask me anything about like science or math. Feel free to ask. Hi, I'm Lydia. I'm a third year. I
And hi, I'm Joshua. I'm a second year studying Git. Yeah, I'm a faculty TA, and yeah, you know what to do.
Really quick, Rebecca and Amir couldn't make it today, but they're also our part of our TAs. We do all have like an introduction post on Piazza, so feel free to introduce yourself there, and we also have our own introductions there as well. Yeah, okay. So we'll talk a little bit more about what you'll be learning in this decal. So we have the basic stack. This is everything from HTML, CSS, and JavaScript. So the very bare bones of what we think every web developer should know. We teach all that. And from there, we teach everyone front end as well. So this is a lot more than what one might think is just static sites, but front end goes into a lot more deeper things like data processing, data manipulation, showing the data. A lot of the logic is actually nowadays, a huge part of it is done through front end due to a lot of frameworks that make that allow us to do that. Additionally, we teach you a lot of UI UX design principles as well, because we think that's also really important as full stack development decal, right? We want to teach you everything that you need to know for full stack. Yeah, and Drew will talk more about backend.
Yeah, so like Kim said, the front end serves kind of an essential purpose. We'll go through the semester to help you understand kind of the differences between these. But the front end is kind of what the user sees, and the back end makes up a lot of what we as computer scientists do. And so a lot of, if you've ever heard of like machine learning, all those kind of fancy algorithms, a lot of that takes place on the back end, where we have the computational power to manipulate the way that users interact with our website. And that's the main way that we provide services to the user. And so both components are really essential to today's development environment. There's 100 million, if not billions, of web pages out there. So the question is, how do you distinguish yourself and your product out of thousands? And so with proper design, good front end, and strong back end, we hope that you'll see the advantages of a well-built website. Okay. Mark?
All right, so before going on, I'll talk a bit about the course layout and what you'll be learning throughout the entire semester. So as we prefaced in the last slide, you'll be learning kind of 3 different categories of materials. Basic stack, you can see here, just HTML, CSS, JavaScript, if you've heard of those technologies. Front end and back end. Front end will also include UI UX, which isn't technically part of the front end, but we lump it in there for the sake of our curriculum. Let's dive a bit deeper into what each of these are. So what is the basic stack? Don't try searching up basic stack on the internet. You won't find anything. That's just their own term for basically what most people call vanilla JavaScript. So HTML, CSS, and JavaScript form the core of the web, and everything, whether it's the back end, front end, ends up compiling to JavaScript somehow. If you want to be able to see it in your browser, on your phone most of the time, it also uses JavaScript if you want to use that kind of language. Yeah. We'll also be teaching you about the basics of the internet. So if you've heard of domain name system, DNS, we'll be teaching about things like A records, C names, and all you need to do to be able to basically put up a website on a URL and configure that URL to show your users what you want them to see. We'll be talking a bit more about the basic stack in the next couple of lessons, and this will be about the first 3 weeks of the course. Next, we'll talk about what the front end is. So as Kim prefaced just a bit earlier, front end is what the user can see. So we'll be using Facebook a lot in this course as an example, because Facebook is very active in the development world. So let's say you log into Facebook, right? You scroll through, you make a post, you look at your profile, you look at another person's profile. That's all because of the power of the front end. So as the name sort of implies, it's what the user sees on the front of your application. Everything you interact with, all the buttons, all the inputs, all that good stuff is part of the front end. And we'll be teaching you specifically React. If you haven't heard of React, it's what most people would call today's most popular front-end framework. And it was actually created by Facebook for Facebook themselves, and also used in pretty much almost any other app that you use today on the web. We'll also be teaching you UI UX in the form of Figma, Adobe Illustrator, as well as just general design principles, including human-centered design, if you've heard of that. And we'll also be teaching you some other various fringe technologies such as Sass, Next.js, server-side rendering, Gatsby, the list goes on and on. But yeah, here you can see some companies that are actually known for contributing to the world of front development. I know Airbnb has a great style guide that we'll have you follow as soon as we get to the React lessons. Instagram, everyone's interactive with. Khan Academy also has some great lessons there. So that'll be a big part of the course, around half-half. The other half goes to backend. As Drew talked about in the last couple of slides, the backend is what makes everything tick. So sure, you have your post that you put into Facebook, you type in whatever you want, you press post, but what happens after that? To give a pretty abridged version, it basically is sent to Facebook servers. Facebook servers are just like, oh, this guy just made a post, let's save it to our database. So that way, next time you reload your page, you see your post still there because now it's permanently in Facebook's database. So what we'll be teaching in backend is a couple technologies. We'll be teaching you about APIs. You don't need to know what an API is right now. Obviously, we'll be teaching you that soon. But if you are curious to learn more, we're going to teach you specifically REST APIs. We'll also be teaching you Node.js. So Node and React are kind of seen as counterparts to JavaScript. JS, if you don't know, stands for JavaScript. So React and Node are both JS frameworks, but React is built for the front end and Node is for the back end. So both tend to work in tandem. We'll be also teaching you MongoDB, which is a super popular NoSQL database. If you don't know what that means either, don't worry about it. And we'll also be touching upon cloud technologies. We encourage use of Firebase in the course, though we don't directly teach it. We will provide resources if you want to use it in your final projects. And we also will, however, be directly touched upon AWS or Amazon Web Services. Yeah, and backend companies you might see here, Lyft has a very strong ML engineering presence where they use a lot of very common backend technologies that contribute to a lot of open source libraries. Obviously, Amazon and Google have their own cloud services just for a lot of backend development. And Twitter, like any other social media, has to have a very, very robust backend in order to hold the millions of gigabytes of data that they get on a daily basis. Yeah, I'll pass it back to Kim and Drew to talk about the course structure.
Okay, thank you, Samar. So to kind of cover just what was covered in the info sessions one more time so that you know what you're getting into with us. This is a 3-unit decal, so it is heavy. Some other 3-unit classes include chemistry, others, I don't know, but it's a lot. It's a lot of content. You'll find that web development consists of a very, very diverse array of technologies: front end, back end, different languages, different syntactical constructions. Just a whole array of technologies that you need to learn, each with their own rule sets. And so a lot of times that can be very frustrating, but we're here to guide you through it. And we hope that you'll stick around to the end and also gain the tools you need to learn any technology, not just the ones that we teach you. This course we've designed it to be very interactive. So there's lesson plans, which you can view on Notion, on the course website. Projects and homeworks. Like I said, it's a 3-unit decal, but ultimately you get out of it what you put into it. The more effort you put in towards making the products that you want to see yourself, products that you're proud of, the more better feedback we can get towards making you a better developer. Like I said, this semester we're pioneering our course website. Prior to this, we were using a Notion. So if you guys have any feedback about that, we'd be happy to hear it. Also, this semester, we have a great course staff who you've met, multiple TAs, multiple instructors. This is a decal, which is part of the university. And so we put pedagogy first. We want you to learn, and we're eager to teach. So however much you value that, we hope that you find our teaching satisfactory. And to support you, we'll be hosting multiple office hours. There will be course staff here after lecture if you have questions, whatever you need to get the support you need to succeed. And then obviously, just like any other course, make sure you read the Piazza. We'll be centralizing all of our course communication there. So look on Piazza for updates, ask questions. It's just like any other course Piazza. Before I move on, I'll just go over briefly kind of the philosophy of this class. In my opinion, this class is two parts. We learn from you just as much as you learn from us. So this semester, with the creation of our website, we're also pioneering the creation of a textbook for this class. And so over the course of the semester, all of our content is always under development, always under review. So if you find anything confusing, difficult to read, if you want to know more about a particular technology, if you find that something is not sufficiently covered, please let us know. We value your feedback a lot, and we'd be happy to get you involved in making this course even better than it is. And the second part is that you learn from us. And like I said, we're going to cover a very, very, very broad array of technologies, and we're going to try to run you down the entire stack. And that can be very overwhelming, but like I said, I think the payoff is well worth it. And with that, I'll pass it to Kim to talk more about the course policies.
All right. Yeah, so I'm going to talk about the course policies. I think Drew did a really good job of like explaining about a lot of the way the course is run. So just reiterating again, everything's on Piazza. So if you have any questions or if you want to check weekly posts, weekly announcements, when homeworks are due, when office hours are, when Piazza is your one-stop for all of that information. And just some other logistics, lectures are every Tuesday and Thursdays from 6:30 to 8 p.m. It's here, so you guys know, you already found it, so I'm pretty sure you know it's Physics 1. And our attendance policy is that you're allowed up to 3 unexcused absences. We have one master attendance and absence form used for all lectures, and in every lecture, we will give like a magic word given by whoever's teaching that lecture, and you'll input that into the form. So even if you can't make a certain lecture, we do want you to fill out that form as well with a reason for why you can't go. Just to reiterate, we know it's like a COVID semester still, so if you have like any worry, concern about being exposed to it, you are able to just let us know that you are, you have a COVID or you have, you're worried about, you might have had exposure to someone with COVID, and we will be lenient with that. But we do want to stress that attendance is mandatory, and the reason why we make it mandatory is because our content is pretty fast paced, and we want everyone to, be here to be up to date with all of our content. So with that, some unexcusable reasons are like, oh, busy with homework or something like that. We'll kind of work on that with the case-by-case basis, but definitely do feel free to reach out to us about any concerns about that. Yeah, and a little bit more about how grading is going to work in this decal. Homework is 50% of your grade, project 1 is 10%, project 2 is 10% as well, and project 3, which is the final project, in which is your group project with like around 4 or 5 people, or it's subject to change depending on what we decide closer to that time. But that is also 10% for proposal and 20% for presentation. And yeah, like we said, we are a decal. We are really fast-paced compared to other decals, but definitely we do care about like your mental health prior to every other thing, right? So if you have any concerns, like I said again, don't feel afraid to reach out to us. We'll try to work with you on a case-by-case basis. Yeah, and I do think that is it for just like our whole brief logistical and what our decals about. And we have our first lecturer, Alex, who's gonna teach you, give you a little intro to our first lecture.
Thanks a lot, Kim. And yeah, today we are going to very, very briefly talk about HTML, CSS, and JavaScript. It's really impossible to cover like all 3 technologies in one very short lesson. And we actually plan to teach you all HTML, CSS, and JavaScript over the next 3 weeks. And this lecture simply serves to kind of like give you a feel of what web development actually is and what are these HTML, CSS, and JavaScript that we keep talking about. And before we dive right in, I do want to mention the house metaphor. It's a very popular way of explaining what is HTML, CSS, and JavaScript. So you can essentially think of any website as a house. And for a house, you first of all need to have the skeleton of the house, right? So for instance, the walls, the roofs, the doors, and the windows. And if you think of website as a house, and then HTML will be the skeleton of the house, the skeleton of the website. Okay, so it's essentially everything that's the actual content of the website is what the HTML is in charge of. And for CSS, it is what makes the house pretty. So essentially all the decorations in the house, the furnitures, the curtains, the lamps, and CSS, if you only use HTML in a website, the website is going to be looking very, very like old-fashioned. But after you add CSS, it's going to be much prettier, and all the user, for instance, once the user click on a button and the button changes color, that's what CSS is. And finally, we also have JavaScript. And JavaScript is what makes the website smart. So in the house metaphor, you can think of JavaScript kind of like Alexa for your house. And you can simply shout to your Alexa about like shut down the curtain, and then the curtain will close down. And JavaScript is essentially the same thing. It makes the website more smarter, and it makes the user interaction much more easily. So for instance, when you log on to Facebook or when you try to sign up for a Facebook account, JavaScript is behind all this. And this is one of the slides that's taken from a few lectures in the future. And this is a slide from our HTML lecture. And as you can see here on the left, on the left of the screen, you can see there's a short code snippet of HTML. And you can ignore the doc type for now. But essentially, what HTML is a way for marking all the content on the website. So essentially, you see on the second line, it says HTML. And this is essentially kind of like a feature of HTML. So HTML is made up of opening tag and closing tag. So if you look at the second line, it says HTML. That's the open tag for HTML. And if you look at the last line, it says slash and then HTML, and that's the closing tag for HTML. And all HTML can be made up of essentially an open tag and then a closing tag. And you can see that inside these HTML open tag and HTML closing tag, there's a body paragraph. There's like a body tag, also an H1 tag, and also a P tag, which means that HTML, you can actually nested all the HTML tags inside one. We'll be going over this in much more detail later in weeks, but this is essentially an example of HTML. And you can see inside the body, we have H1, and H1 stands for the first headline, essentially the largest headline. And it says hello world. And on the right of the screen, you can see there's so essentially here on the top right of the screen, you can see hello world rendered onto the screen. So this is a screenshot of the code snippet being rendered onto the browser. Okay, so H1 hello world corresponds to the big hello world title on the screen. There's also a P tag down below, right at the line 5. It says this is an example of HTML, and P tag stands for paragraph. So essentially, if you want to create a paragraph, you put things inside P tag, and then it can be rendered onto the screen. So as you can see on the right, it says this is an example of HTML. That's essentially the P tag rendered onto the screen. And you can also kind of like think of HTML as a tree-like structure. So on the bottom right, you can see there's body and then 2 arrows pointing to, first of all, H1 and then a P. And this is essentially the structure of an HTML file. For instance, if you see on the left, it's a body tag, and inside the body tag there are 2 other tags, so H1 tag and P tag. And this corresponds to the tree-like structure on the right. And it's okay that it feels kind of confusing right now, but we'll go over HTML in the HTML lecture later. Actually, before I move on, are there any questions? Okay. And now let's take a look at CSS. And for a very quick recap, HTML is kind of like the skeleton of the website, and CSS is what makes the website prettier. So the function of CSS is it styles all the HTML that we have written. So if you see on the past slide, on the previous slide, the hello world, and this is an example of HTML, they don't have any styles here. So when we usually have a website open, those texts are usually rendered like in different colors, in different fonts, in different sizes. But without CSS, we can't do that at all. So after we have CSS, we can add font to the text. We can change its color. We can even change the style layout, and we can also add animations to the website. And everything's become very exciting. And here are the CSS basic syntax. So how do you write CSS? Is that first of all, there's a selector. And after a selector, there are statements. So for instance, on the left, you can see it's P followed by curly bracket. And the P is essentially a selector. It selects the P tags inside the HTML file. So for instance, on the right, there is a P tag. It says, I want more styles today. And on the left, the CSS file here, the CSS snippet here, is select that particular element and then change its text color to violet. Okay, and it also changes the text decoration to underline. And as a result, the text will become violet, and also there will be an underline under the text. And finally, we also have JavaScript. So JavaScript is a very high-level language, very similar to Python, which means you don't really need to think about memories and all that stuff. You can simply write code. And it's a powerhouse of essentially all web applications. And it's in charge of all the interesting behaviors on a website. So for instance, if you click on something and it pops up alert and says, for instance, sold out, that's essentially what JavaScript is in charge of. And if you do have some Python syntax, if you do have some Python experiences, you might find JavaScript to be pretty similar, and it is. And on the right, you can see this is a very short snippet of some JavaScript. It first of all defines two variables, and then it calculates essentially the force. And we are not going to go into this in too much detail right now, as this is the job of later lectures. But essentially, JavaScript is much more expressive than HTML and CSS. And with the help of JavaScript, you can write some very extensive functions and essentially make the website becomes much more smarter. Okay, cool. Before we move on, are there any questions for CSS, JavaScript? Mm-hmm. Yeah, great question. So there are multiple ways to write HTML, CSS, and JavaScript. The popular way is to separate CSS and HTML and JavaScript into different files. And essentially, you will write HTML in a .html file. You will write CSS in .css file. And you will write JavaScript in .js file. And there's also a way to include CSS and JavaScript inside HTML file. We'll talk about this in much more depth later this week. But yeah, great question. Any other questions? Alrighty. And we have just very briefly talked about HTML, CSS, and JavaScript. And now let's take a look at how a website would look like if we only write it using HTML, and then using HTML, CSS, and finally using HTML, CSS, and JavaScript. So let's say we want to sell a very old model of a Macintosh. if we only use HTML to write the website, it will look something like this, like the landing page of our store. We have the title, Macintosh on the top left, and then a very big image of the computer afterwards. And then we also have learn more and purchase buttons on the right. And you can achieve this simply using HTML. You don't really need to use any CSS to achieve this. But you have to agree that it looks kind of weird. And this is just the nature of HTML. It's only in charge of the content of the website. It's not in charge of styling it. And so let's see if we add just a little bit of CSS, what will happen. Okay, so now we have add a little bit of CSS into the website. As you can see, the title, it changes, first of all, its position. And if you look at this carefully, it also changes font and size. And we also see that the learn more and the purchase button is now centered. And there's kind of like a margin between the learn more and the purchase button. And also we notice that the image is filled inside the entire browser's window instead of like awkwardly placed in the center like before. So yeah, this is essentially the power of CSS. You can, with the help of CSS, already write some very, very pretty static website. And the keyword here is actually static. So if you don't use JavaScript, you cannot really make the website smart. And since we actually want to sell our customers on Macintosh, we do want to enable our website the ability to inform the user. So let's say our Macintosh actually sold out. And we want the user to be able to, if they click on the purchase button and an alert pops up that says that the Macintosh was sold out. And this is only achievable by using the help of JavaScript. And as you can see here on the screen, if the user clicks purchase, there's an alert that pops up and it says Macintosh was sold out. And this is what the website will look like with the help of JavaScript. Great. And do we have any questions so far for what HTML, CSS, and JavaScript does? It's okay for you to only have kind of like intuitive understanding, because this is what our first lecture is trying to achieve. Okay. And before we move on to kind of like the next part of our lecture, I do want to mention some tools that we use. And these, if you are into computer science or have ever programmed before, these tools should be pretty familiar to you. And if you have not, it's completely okay, because these are very, very easy to download, install. First of all, we use Chrome. We don't use Safari or any other browser, simply because Chrome has the best support for all the language features and also the syntax that we're using. And we find Chrome to be the most stable browser right now. And Safari is really kind of like a Chrome downloader, to be honest. And secondly, we have VS Code. It stands for Visual Studio Code. It's an editor that's created by Microsoft and it's used very widely in our industry. And we also, right here in this course, we also recommend you all to use VS Code. There's also other editors out here, for instance, Sublime Text, but VS Code simply has the best support for all our syntaxes, and it's very easy to use. It's also very easy to download. You simply Google VS Code, and then you click on probably the first link, and then you can download it. And thirdly, we have our terminal. And terminal is essentially a way for us to interact with the computer only via text. And the usual way of us interacting with the computer is through clicking. But if you're using a terminal, you cannot click on anything. You can only use commands. And sorry. And by typing in commands, you can essentially interact with the computer that way. Now, before we move on to some live demo, do we have any questions for our tools? Alrighty, and actually before I do our live demo, let me briefly introduce what Git is. So Git is a version control tool for some software engineer or programmer to store their code. Essentially, it's a way, and there's also something called Github. It's essentially a website that uses Git to help us store our code. With the help of Git, you can essentially write code anywhere using any computer. And with so there are a lot of commands here. I know it can be a little bit intimidating, but there are only like 3 commands that we use day to day, and the other 4 commands are mainly for kind of like just status check, like what is Git doing right now, and so GitHub, so Git and GitHub is essentially 2 very popular tools, and it's crucial that we are able to use it properly. And so yeah, I think let's jump into a live demo and see what Git can do. And right now I'm opening up the terminal. And if it's the first time that you have ever opened up the terminal, at least in the MacBook, you first of all type command space, and then you type terminal, and then here's the terminal. And to work with terminal, we first of all need to know a few very, very helpful commands to essentially to navigate inside the terminal. And you can find all the commands here in the next slide. Essentially, the command that we are going to use today is cd. It stands for change directory and also list. It's ls, short for list. And let me just change directory to another directory. Okay. For instance, right now I'm in the web app Berkeley folder. And if I type out list, ls, it will list out all the folders and all the files inside the current folder. And let's say we want to go to another folder, okay? Let's say we want to go to the lectures folder. What we can do is by typing cd followed by lectures. And then as you can see, here it changes from web app Berkeley to lectures. And this means that we are now currently residing in the lectures folder instead of the web app Berkeley folder. And cd is essentially a way for us to change between directories. And let's say you have accidentally entered the wrong directory and you want to go back. The way you do this is by typing cd space followed by 2 dots. And if you click enter, as you can see, it goes back to web app Berkeley folder. And now let's go into the lectures folder again, lectures. And you might notice that after I type LE, somehow it auto completes. And this is achieved by typing tab. So essentially, if there are no like conflicting names between the folder, and if you type tab, it will auto complete the rest of the name for you. And we hit enter, and then we enter the lectures folder. And now, Okay, I guess here's a third command that we need to use. It's called make directory. So let's go ahead and do that. So mkdir. So make directory, the use is essentially creating a new folder inside the current folder. So let's say we want to create a folder called lecture 0 live demo. And we can do this by typing mkdir followed by space and then the name of the folder. And after we hit enter, if we type out list, as you can see, there's a lecture 0 live demo right now in our current folder. There's also an auth example. This is just something that I forgot to do. Okay, right now we have our lecture 0 live demo folder. Let's go into it. And you might notice that right now there are a lot of commands here inside the terminal. And it looks kind of like annoying because I don't want the terminal busy. A way to clear all this out is by typing clear, and then the terminal is clean. And right now, let's try to create a file. And the way to create a file is by using the command called touch. And let's say we create something called index.html. So essentially, let's create an index.html file. And after we hit enter, and if we list, as you can see, a file called index.html is right now residing inside our folder. Okay. And before I move any further, do we have any questions so far? Or if you are following along, do you have you encountered like any problems? All right. And yeah, usually in this type of live demo lecture, we do encourage you all to follow along. This is probably the best way to kind of like learn it. And okay, now just to recap, we have created a folder called lecture 0 live demo, and then we have created a file called index.html inside that folder. And I do want to mention one pretty useful command. It's called open. And if you do open dot, you will open the current folder in a very graphical, familiar way for us. And if you sometimes find like manipulating file using terminal to be tricky, you can always do open dot, and then the graphic interaction will jump. And right now we have this index.html. And let's open it using Visual Studio Code, and let's take a look. So right now inside this index.html, we don't really have anything. And this is because we have a write entity here. But right now, let's just write something very simple. Okay, so I have written HTML, P, and then hello. So if you remember from one of our previous slides, we have essentially here created a HTML file. We have created a P tag. Let me just zoom in a little bit and close on. Okay, and right now we have created a HTML file. And right here we have the HTML tag. Here's the open tag, and here's the closing tag. And inside the HTML tag, we have a paragraph. And the paragraph is that hello. And this is essentially a HTML file already. And we can actually open up this HTML file using Chrome. So let's open up a new window. and then go to File, Open File, and let's find the corresponding stuff. So I'm at Berkeley, lectures, lecture 0, like demo, and this is the HTML file that we have just created. Let's open it up. And I don't know whether you can see or not, but there's a hello here. And this is our very first, essentially HTML file. And we can change this to something more typical, like hello world. And if we save it, we go back to the browser. If we hit refresh, as you can see, the world appears. Cool. Now we have our very first index.html. And let's say we're very proud of that, and we want to store it somewhere on GitHub. And GitHub is essentially a place for software engineers and also programmers to store their code, also share code with others. So let's say we're very proud of our work, and we're ready to save this to GitHub. What do we do? First of all, we go to the terminal, and then we type git init. There's a bunch of warning sign, but git init, it will initialize the empty Git repository inside your current folder. And what this does is that it means it signals to the Git that it will start tracking all the like not really tracking, but start kind of like looking at all the files that you are creating inside this folder. And right now, after we type in git init, and if we do git status, as you can see here, it says no commits yet, and untracked file index.html. And this is essentially saying that, okay, the Git detects that inside this current folder, there's a file called index.html, which we just created, but it's not tracked yet. And essentially what Git does is that it will track your file, and then you can save all this like changes into Git, and then you can let Git to push all the changes onto Git. So it actually gives a pretty useful hint here. It says use Git Add to include in what will be committed. So let's say index.html is what we want to be committed to GitHub. So let's do git add index.html. And if you feel lazy and you don't want to type out the whole name, like index.html, you can also do git add dots. The dots essentially stands for all the current changes inside this folder. So let's do git add dot. And now let's do git status again. Git status is actually a way for you to check what's the status of the current folder, of the Git inside the current folder. And if we do Git status again, as you can see, it changes from untracked files to changes to be committed. And so there essentially are two stages to committing a file to GitHub. First of all, you need to add it. This means that the Git will actively track the file. However, no changes are saved yet. And to save the changes, you need to do git commit to save the change. So let's do git commit. And you can also add a commit message to your commit. So let's say you can add it by using the -n. And then let's say create index.html. And if we hit enter, as you can see here, it says create index.html. And we have successfully commit the one file change, file insert, 5 insertions. Essentially, we've only written 5 lines of code, so hence the 5 insertions. And if we run Git Status again, as you can see, it says on branch master, nothing to commit, working tree clean. This essentially saying that all the changes inside the current folder are saved to Git. However, right now we haven't really pushed onto GitHub. And since we do want to share our lovely website with our friends, we do want to have it onto GitHub. Right now, we only have it stored on the local on the Git on the local computer. And to use GitHub, let's open up a new browser window and then go to GitHub. It's essentially github.com. And if you haven't signed in or logged on to GitHub before, you probably will see a different page. But in here, once you have created an account, here you will see a new repo button. And if you click on it, you can create a new repo this way. And let's say we do lecture 0 demo. Okay, and all the other stuff are, oh wait, already existed. One. Okay. And all the other stuff, we can just leave it optional. And let's hit create repo. And then here, we have this repo. And GitHub actually conveniently give you some instructions on how to connect to the local folder. So for instance, here, we can simply copy all the code and then go to our terminal and then paste it. And then now we have successfully pushed all the files onto GitHub. If you do want to learn more about what these commands stand for, do check out our homework assignments. I believe it's assignment 0. And in assignment 0, we do cover Git in much more detail. But once we have copied and pasted code and push all the changes to GitHub, let's refresh the page. And here, inside here, you can see we have successfully pushed our index.html file to GitHub. And here, if you open it up, as you can see, we have HTML, P, hello world, closing tag P, closing tag HTML here on the GitHub page. So this is how we will push something from our local computer to a remote one, which essentially here right now is GitHub. Do we have any questions so far? I know that I covered this pretty quickly, so it may be still a little bit confusing right now, but once you have finished homework 1, I believe it will be much clearer to you how you will use Git. And essentially the most commonly used commands are all the commands here listed inside the slides. And as you can see, Git Add Dots, this is the first command that we use. And then we use Git Commit -n followed by the message. And this way we can save all the changes to the local Git. And then we can push it by either copying and pasting code from GitHub or by using this command. It's git push origin main. It's essentially pushing the local saved changes to the GitHub repo main branch. So essentially Git commit, it only saves to the local Git. But by using git push origin, it pushes the local save changes to a remote one. And in our case, it's GitHub. And we also have Git Status, which is you can check the current status of Git. You can run it like anytime you want. And we also have Git init and also Git branches for viewing all the branches. You can learn about branches on how to create new branches later. But yeah, do we have any questions so far?
Do you need to include the origin
Oh yeah, great question. So I believe you do need to include that, but I'm not too sure about this. And what Git push origin main does is essentially saying that we want push to the origin. Origin is kind of like a name for GitHub. You can also set it to other names, but the default one is origin, and the main is the branch name. So right now the default name is main, and if you're using an older version of Git, it may be master. So in my case, it's actually master. And but yeah, and I believe there's a way to kind of like set your default settings to, if you do git push, will automatically push to kind of like the default setting. But I'm not too sure about like whether I have the default setting out right now. So does this answer your question? Okay. Do we have any other questions, concerns? Mhm. Yes, you will have access to the slides after. Mhm. Yeah, we'll be posting recordings, right? Do we have any other questions? The question is, how do we push the file to GitHub? Oh, how does it get there? That's a great question. I don't actually know. It's probably by some like black magic by GitHub, but um, essentially so essentially computer science is all about abstraction, right? You don't really need to understand everything for it to work. And right now, what we do need to know is we use, for instance, git push, this command to push files onto GitHub. But for the internal kind of like working of Git, I don't really know. So any other questions? Alrighty. And if you do come up with some questions like after a lecture, feel free to come up to like here and ask us, or you can also ask the questions on Piazza. And also here are some useful terminal commands. Let me just recap it real quick before my computer run out of battery. But CD stands for change directory. And as you can see in our previous live demo, you use CD to change into a directory that you, for instance, have created. So for instance, you have just make directory a folder called, let's say, example. And to change into that directory, simply use CD example, and you would be inside that directory. And ls is used for listing all the folders and also all the files inside the current directory. And open dot is a very useful command if you do want to kind of like interact with the terminal. Like instead of interacting with the terminal, you interact with the graphical way, like the normal way. And we also have make directory and KDR. This is used to create a folder, and it will have the name of the folder followed by the mkdir. And there's also touch file name. So essentially, you can create a file called file name by using like touch file name. In our case, we do touch index.html, and that way we create a file called index.html. Before we move on, do we have any questions for the useful terminal commands? All right. And now that's the end of this lecture. And what? Yeah, for sure.
Okay, I just want to mention really quick that homework 0, which is just getting started, is due on February 8th, which I believe is next Tuesday. Let me see if I can actually show you like our website and where to find the homework. So our two main places where you find all of our content and all of our updates is Piazza and fullstackdecal.com. So it is taking a little to load, but I'll show you in a bit. Hopefully it doesn't die before the battery runs out. But yeah, you guys can see really quick already that there's some lessons here. So the reading is lesson 1, and the assignment is found under assignments, homework, and homework 0, getting started. So it's kind of loading, but yeah, that's where you can find it. And you should have been added to the grade scope already, but if not, there's the course code on Piazza. And yeah, that's where you'll be submitting all your homework. Yeah, I think that's all I have to say.
Alrighty, and I'm going to end the record. I'm going to end the recording before I say.
Yeah.
All right, and let me just end the